Hi, I'm Dr. Bruin and welcome back to part 19 of these commentary videos which sit alongside my A-level chemistry speedrun series. This is a flame calorimetry question in which we're looking at the energy changes that happen when a fuel is completely combusted. So to begin with, you're going to need your equation for Q. So this equation tells us that the energy change that happens we can find by multiplying together the mass of the thing that changed temperature. So in this instance, it's the water. It is definitely not the fuel. And we're multiplying that by the specific heat capacity of the thing that changed temperature. So here it's the water, and multiplying that by the temperature change. And then the other equation that we're also going to need is our equation for delta H, and to do this we're going to take our value of Q, convert it to kilojoules, and then divide it by the number of moles of the fuel that was burned, and this is where we're going to need the mass of the fuel, but not in the first step. So before I can work out a value for Q, I need a temperature change. Now, of course, in chemistry, all of our temperatures are in Kelvin, but actually here, because it's temperature change that I'm interested in, and because the size of a Kelvin is the same as the size of a degree Celsius, I don't actually need to convert the two numbers first. So I'm just going to work out that delta T is 41.2, take away 20.7, which is 20.5 Kelvin, or degrees C, same thing. And then next we're going to work out our value for Q, so we're going to multiply together those numbers and get 10,282 joules. Now, as we said, we're going to need to know the number of moles of propanol that we've burned. So this is where we're going to use that mass, that 480 milligrams, which of course we're going to have to convert into grams, and we're also going to need the relative formula mass. And remember, this is a really easy way to lose a mark. It's amazing the number of people who could do quite complicated chemistry but lose a mark because they worked out the MR wrong. So just double check you're working there. Okay, so that 480 milligrams we're going to convert to grams by dividing it by 1,000. And then we're going to work out that the number of moles that we have is that new mass in milligrams divided by the MR that we just calculated, and that gives us 0.008. So then we've worked out an overall energy change for the reaction, but we want to know the energy change if we'd burned 1 mole. We haven't burned 1 mole, we've burned 0.008. So we're going to take our value of energy and divide it by 1,000 to put it into kilojoules, because delta H is always going to be in kilojoules per mole, not joules per mole. And then we're going to divide that by the number of moles that we just calculated, giving us an answer of 1,285.25. But of course, this needs to be to a sensible number of significant figures. So I'm going to look at my data in the question. I've got 480, I've got 120, and I've got the specific heat capacity, and I've also got the temperatures, and all of those are 3 significant figures. So therefore, I'm going to give my answer to 3 significant figures. So, you know, the first 3 we look at there, what's going to be left, then we look at the 4th one, and the 4th one is the one that's going to tell us whether to round up or down. Here it's 5, so we round up, so we get 1,290 kilojoules per mole. Thank you very much for watching. I hope that was a useful run through of that question. And if you are finding it useful, then don't forget to like, subscribe, comment, tell me what you'd like me to cover next, and also share the channel. And I'll see you back soon for some more A-level chemistry.